exams to be challenged, and here we are preparing for CBSE Math 2025. For first chapter is the real number chapter. So for few things, fundamental understanding is required. First theorem talks about this composite number. In this composite, numbers can be expressed as a unique, the factorized form. What does it mean is, see, a 12 is a composite number, and this can be broken as a 2 into 2 into 3. So so this number of 2's and number of 3's, these are unique. Even if you write in a different order, that doesn't matter, but this order doesn't matter, but this prime factorization is always unique for a composite number. Second theorem talks about if a square is divisible by p, so then a is also divisible by p. See the example, if 6 square is divisible by 3, that means 6 is also divisible by 3. So this is the meaning of this theorem. This theorem will be very much used for your proving root 2, root 3, root 5 are irrational. So during those that proves, okay, this theorem to be used. So if we see that what kind of question can be expected, it can be expected like first set is root 2, root 3, and root 5. Okay, prove that okay these are irrational. Second combination of the same thing can be shown as a 2 into root 3, you prove as irrational. 2 by root 3, you prove as a irrational. Okay, or 2 plus root 3, you prove as a irrational. So like different way, but for this different way of presenting will differ your proof also. Okay, so all these are based on that. So these are the fundamental proof. It is given in the book. Please follow the same process. For this part, you know that generally what we do, that 2 by root 3 is p by q, and you think this is a rational number. Then what happened is that now root 3 can be written as a 2q by p. So this shows this is a rational, but root 3 is already proven as irrational. These are this root 2, root 3, and root 5. Uh, you can take um, you, you need not to prove separately. You can mention that root 2, root 3, root 5 are already proven as irrational. So that contradicts. So this shows a rational, but this part is irrational already proved. So this contradicts. That means this assumption itself is not correct. So that is the way this these composite problems like a 3 plus root 5 or 2 by root 3, all these are proven. Okay, next coming to the LCM. LCM, you are very much familiar. You have to do the prime factorization for both LCM and HCF. Okay, HCF is the common part, and LCM is a common but bigger envelope of all the numbers. Okay, but they are all three numbers should exist. Rather, HCF is a kind of a set, a common part between these two numbers. Or if the three number, this is the only common part. This is the only common part between these three numbers. Okay, so these are HCF and LCM, and this is also important theorem, important the properties. I'll say this product of two number is equal to their HCF and their LCM. Okay, with these properties, okay, uh, one marker may come. Then there will come that some of the word problems of LCM and HCF, which is a real life examples or real life some problems we try to solve by this. these word sums. So let us move and see. Okay, let us solve a few questions from the past question papers. These you know already that HCF and LCM will be product of, if the numbers are this, so this product also will be 3 into 70. So this will be the answer. Proof of 3 plus root 2 irrationality we have already discussed. So you take this is P by Q, and then next line will be root 5 equal to P by Q minus 3, and that will give P minus 3Q by P. So these, as P and Q are uh, a prime number, so is a these also is a rational number. These will also give a rational number. So but root 5 is already proven irrational, so from that logic that okay, this our assumption, this assumption is a wrong assumption. That is the way to prove. Here for else, for integer express this number HCF. HCF means what? This is the common part. So here this is between this common part. For x square and x2, x square is common. For y5 and y square is common. So HCF of these two numbers m and n will be x square and y square. Sum of the exponent of prime factors for prime factorization of 196. So you break 196. Okay, it will be 2 to the power 2 and 7 to the power 2. So the fact this will be the answer, because it asks that exponent, sum of the exponent 2 and 2 is exponent, so answer will be 4 here. Here again that number is given 336 and 54. So between these you find LCM, find HCF, and you prove, you multiply that LCM HCF, and then show that okay, and you multiply other side is 336 into 54. So both the side it should be same. And next one is a example where a number which is divided by 12, 16 and 24, and 7 will be the remainder every case. So for these three you have to do the LCM first, and this LCM for this this will be 48, and is LCM is 48, so 48 plus 7 is 55. So if you see this 55 divided by 12, 16 or 24, every time you will get a remainder of 7. So this is a LCM what sums. Next one is okay, again it is asked for HCF. So if they are broken like that, so this is a good for us that we okay, these one steps are okay less for us to calculate. So here 2 square and 2 cube, so common is 2 square, and 3 cube and 3 square, so 3 square, 5 4 5 to the power 4, and here is only 5, so only 5 is common. So this will be your HCF for that. So 4 into 9 into 5, you multiply, get the product, and that is HCF. We have discussed already about that. 2 by root 7 you have to prove irrational. This number, okay, next one is asking it is a irrational number or integer number. So after, so you know how to simplify. What you have to do, you have to multiply root 4. Basically our target is the denominator, so you multiply root 5 plus root 2. So what will happen here? In a denominator will be root 5 square minus root 2 square. Root 5 square minus root 2 square in a denominator, and in a numerator will be root 5 plus root 2 whole square. So if we simplify these on denominator, now 5 and 2, so it will only 3 will be denominator. Now in the numerator what will happen, like if you break this process, a square plus b square plus 2ab, so 5 plus 2, so 5 plus 2 plus 2 root 10, root 5 into root 2. So this is a irrational number, so this cannot be, this irrationality cannot be removed, so answer is your irrational number. So prove that this is a 5 root is irrational. Already we have discussed it. So let us move forward for more examples. So here is also one real example. 42,000 is asked to break in this format. So what you can do here, and it will, your breaking will be like this. So 42,000, if you start breaking by 2 to 2, it will be very long. So what you do that, you break 42 in a 1 and 1000 in a 1. So 42 will give how much? It will give 2 into 21. So 2 into 3 into 7, correct? That is 42. And 1000 is what? 10 to the power 3, correct? So now 10 is a composite number. So 10 you break as a 2 into 5. So that is 2 into 5 into 3 to the power 3. So that means this is a 2. So that means these will give again 2 to the power 3 into 5 to the power 3. Now let us combine these and these. So 2 to the power 4 plus only 1 3 plus 5 to the power cube into 7. So this is the total bracket. So now you find similarity. So A became 2, B became 3, C is 5, and D is 7. So now cell phone is DBAC. So D7 3 2 5 7 3 2 5. Okay, so that's the one. So you see here learning is that if any kind of big things we factorize, it is always better to do in a little bit broken way, so that you can get the quick result. This one is already we have discussed it. So same way, if you write p by q here, 2 plus 3 root 3, so equal to p by q. So next line what will do, this 2 you take this side, so 3 root 3 is p by q minus 2. This is q p by 2 q. Okay, now again this 3, now you take it this side, so this 3 will come here. So okay, so your root 3 will be p minus 2q by 3q. So this is a rational number. pq is a prime number, so that if you put that, this fraction will be this fraction will represent a rational number. So but root 3 is a irrational, so the first assumption was wrong. So that is the way you have to put these on. Okay. Next is next one is the total number of factors of a prime number. So any prime number can be broken in only two parts. Any prime number can be broken in two parts. That number 1 and that number. So if it is a 3, so 1 and 3. So that means only two factor can be. So answer is 2 here. Okay, next one is again a word sums. 2002 number and 2618 number of cartoons can be. Okay, so is the same height. Okay, so you know that. Okay, these problems, when we are trying to find some common lesser common between these two numbers. Or okay, so in that case, this is a HCF problem. You have to do the HCF of that, and that will be the answer. That many bottles you can stack together. That will be the common factor. It will be divisible to the both the numbers. Next one is okay, 3 baskets. So 50, 90, and 120 is, so again equal number. So some common denominator we are looking between these three numbers. So again it will be a H-shaped problem. Minimum number of baskets required. So this is the okay, and then okay, so that's all about here. So we'll move to this polynomial chapter next.